Hello everyone. For this tutorial video, I like to explain what differential equations are in general, so that way we can get adjusted to the thought process for solving specific examples in later tutorial videos. As you may be able to guess from the title, a differential equation is one that involves a derivative equal to some function. For example, the derivative of y equals 3x squared. And we can interpret this as asking, what function y will give us 3x squared as its derivative, which we already know how to figure out from integrals. So the answer would be x squared plus constant of integration, because we remember from studying integrals that the derivative of a constant is 0 regardless of the exact value of the constant. So this would logically mean that the constant of integration can have an infinite amount of values and still give you the same exact derivative. It doesn't matter. In a similar way that you can verify solutions to algebraic equations by plugging in your value of x you derived, you can do the same exact thought process for differential equations. So you can plug in y equals x squared and the y derivative part, and you should get 2x. And since we are given 2x in the original equation, that is exactly what we want to solve for. So we know y equals x squared is a valid function for the differential equation. You will hear that a solution that involves an infinite value of the constant of integration is called a general solution to a differential equation, because it does not have one specific value, but has a more generalized set of values. Whereas something with a specific constant instead of the constant of integration is what's known as a specific solution, as a reference to how it has a particular value. Or you will hear also called a particular solution. So for example, if we want to solve this differential equation for a specific solution and not a general solution, we would do this by noticing we have y derivative on one side and terms of x on the other side, so we can simply integrate to get rid of the derivative and figure out the function y. On the left-hand side, the derivative and integral simply cancel each other out without any extra details. But the right-hand side is more complicated, so we would have to memorize different integral formulas in order to come up with a good solution. And we must also be mindful about you will have to add a constant of integration to both integrals because of how you're integrating both sides separately and not just one side. And the constant of integration always appears in an indefinite integral because of how differentiating a constant function works. To make our lives more convenient in terms of finding a specific solution, we can condense the two constants into one constant that would be a simple difference of the two constants, which we do to isolate y by itself. And since we are given explicitly that function of 0 equals 5, we plug in 5 for the y or function value, and we plug in 0 for the x input. So once we do the arithmetic, we get 5 equals 3 plus the single constant, and we should logically conclude that the constant has a value of 2. Now that I've explained how to solve the most basic of differential equations, I can talk about more complicated differential equations that require more algebraic manipulation than the types we have seen in this video, as well as specific labels for different differential equations, like what a separable equation refers to, or what a first-order differential equation is. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.